2.1 million tokens in 3 hours. A $2,400 OpenAI bill. No user errors, just a retry loop that never stopped. Here's exactly why. The article mentions circuit breakers, but doesn't show code. Here's a concrete implementation using Redis to track consecutive failures and open the circuit after a threshold, preventing further AI calls until a cooldown period elapses. The article uses at AI Software Development Kit React and at AI Software Development Kit /OpenAI, which are part of Vercel AI Software Development Kit v5. In v5, UseChat is imported from at AI Software Development Kit React, not AI/React as in v4. Also, StreamText returns a StreamText result with to-data stream response. Ensure your software development kit version is > 5, 0, 0 and check migration guides if upgrading from v4. The article estimates prompt tokens by dividing character length by 4, which is a rough approximation. For accurate cost tracking, use the provider's tokenization, e.g., tick token for OpenAI or the usage object returned in onFinish. Inaccurate token counts can lead to budget overruns or false circuit breaker triggers. Let's break down building production-grade AI features in Next.js 16, how it works, and the exact mistake behind that failure. Production-grade AI features in Next.js are server-rendered or server-action-based integrations that handle model inference, streaming, and error recovery with deterministic cost and latency guarantees. The core mechanic is that every AI call must be wrapped in a retry strategy with exponential backoff, a maximum attempt count, and a circuit breaker. Every AI feature starts with a root handler. It handles authentication, input validation, rate limiting, cost tracking, and streaming. The client never talks to the provider directly, your API key stays on the server. This is the full root handler. It validates input, checks budget and rate limits, estimates cost, streams the response, and tracks cost on finish. Notice we set maxDuration to 60 seconds and use node runtime for long streams. Streaming is mandatory. Non-streaming waits 40 seconds for 2,000 tokens, and users abandon after 5 seconds. The UseChat hook handles the stream and provides loading, error, and stop states. This client component uses UseChat to stream responses. It shows a reconnecting banner on timeout, a thinking indicator while loading, and buttons to retry or stop. The on-error handler attempts to reload after a timeout. AI errors need classification. A 429 is retriable, a content policy violation is user actionable, and a 401 is permanent. Parse the error code and retry after header to decide the action. This function classifies errors based on status code and error code. It returns a category, retry delay, and user-friendly message. Use this in your root handler to decide whether to retry. Cost control is critical. Use Redis to track daily spending per user and globally. Check budget before streaming and estimate cost pre-flight to reject expensive requests early. This code tracks cost in Redis using incrbifloat. It checks user and global daily budgets before allowing a request. The estimate cost function calculates the expected cost based on prompt and completion tokens. Rate limiting at the application layer protects you from abuse and retry storms. Use upstash rate limit with a sliding window. Never use in-memory rate limiters in serverless environments. This creates a rate limiter that allows 10 requests per minute per user. The check rate limit function returns whether the request is allowed and how many seconds to wait before retrying. This is the same issue we highlighted at the start. Here's exactly why that happened. The team deployed a Next.js app that retried OpenAI calls on every 5xx without a cap. When OpenAI had a 15-minute outage, each of 200 concurrent users triggered retries in a loop. With no maximum, the retries cascaded into 240,000 calls, burning 2.1 M tokens and costing $2,400 in 12 minutes. The root cause was a retry configuration with no maximum retry count and no exponential backoff, causing a single 429 to cascade into thousands of retries, each billed at full cost. The fix is to cap retries at 3 with exponential backoff and jitter. Also implement a circuit breaker that opens after 5 consecutive failures in 60 seconds. The key change is setting max retries, 3 in the retry configuration. This prevents the unbounded loop and limits financial damage. This is the exact pattern that caused the $2,400 incident. A while-true loop with no max retries. Always cap retries and use exponential backoff. If you don't set max duration, Vercel Hobby kills your function after 10 seconds. For AI streaming, that's almost always too short. Always set it explicitly. Edge runtime caps streaming at 25 seconds, even if you set max duration higher. Use Node runtime for streams longer than 25 seconds. For agent workflows, use max steps to limit the number of tool calls. Validate tool arguments with Zod and add timeouts to prevent hanging. Treat tool arguments as untrusted input. This agent uses max steps, 5 to limit tool calls. The search tool has a 5-second timeout and validates the query parameter with Zod. If the tool times out, it returns an error instead of hanging. Abstract your AI provider behind a function that can fall back to a different model on failure. Route 80% of requests to a cheaper model like GPT-4o Mini to save costs. This function selects a primary and fallback model based on complexity. On a 429 or 5xx, it waits for the retry after header, capped at 5 seconds, and then falls back to the secondary model. Test the plumbing, not the poetry. Mock the AI provider and test that your root handler validates input, checks budgets, and returns correct status codes. Don't assert on generated text. This test mocks the AI module and checks that the root handler returns a 400 for empty messages. It tests validation logic without making real API calls. Auth is tricky in Next.js. Validate tokens in Edge middleware using the Vercel library, which works without Node crypto. Store refresh tokens in HTTP-only cookies and use short-lived access tokens in memory. This with Auth higher-order function extracts the bearer token, verifies it with Vercel, and attaches the payload to the request. Use it to wrap your root handlers. Cache invalidation is tricky. Tag your fetch calls with a unique identifier and call revalidate tag from your webhook when data changes. This avoids blasting the entire cache. This example fetches a product with a cache tag and revalidates that tag from a webhook. This ensures the product page shows fresh data without invalidating the entire site. To debug AI issues, log retry counts, token usage, and circuit breaker state. Monitor cost metrics and alert if spending exceeds 2x the baseline. This helps catch problems early. Let's run through some common interview questions. How do you prevent unbounded AI costs in Next.js? Cap retries at 3 with exponential backoff, use circuit breaker, and track budgets in Redis. What is the role of a root handler in AI features? Acts as a gateway, validates input, checks rate limits and budgets, streams response, and tracks cost. How do you handle AI provider failures? Classify errors as retriable, user actionable, or permanent. Use fallback models, implement circuit breaker. And a few frequently asked questions. What is the best runtime for AI streaming? Node runtime with max duration set to 6,300 seconds, edge caps at 25s. How do I track AI costs? Use Redis to store daily cost per user and globally. Check budget before each request. What is a circuit breaker? A pattern that stops all AI calls after a threshold of consecutive failures, preventing cascading retries. Let's recap the key takeaways. Always cap retries at 3 with exponential backoff. Use root handler as AI gateway. Track costs with Redis. Implement circuit breaker and rate limiting. Ready to go deeper? Up next, how to build your own AI coding assistant with Next.js 16, OpenAI and RAG 2026 stack, then the new T3 stack in 2026, then how to fix Next.js 16 hydration errors once and for all, and Next.js 16 plus React 19 complete migration guide. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.